Welcome to video 4 of a 4-part video series concerning the National Water Model learning module found on Hyrolearn.org. My name is Easton Perkins. I am a student at Brigham Young University and a research assistant in the Hydroinformatics Research Lab. Today we'll be going over how to complete exercise number 4 found in the National Water Model notebook number 1 titled Visualizing Forecasts in Python. Open up a browser and type in Hyrolearn.org. Once here on Hyrolearn.org, type in the National Water Model. This will give you access to the learning module found on Hyrolearn.org. Click on the National Water Model to gain access. Once you have done that, you should have access to a page similar to this one. This is Hyrolearn.org, and this is the National Water Model learning module here on Hyrolearn.org. This video assumes that you've already worked through the introduction, the module overview that gives you a brief overview of what the National Water Model is, as well as obtained a brief history for it, the outputs of the National Water Model, such as the short range, medium range, and long range forecast, and have worked through the learning quizzes to be able to understand this content more fully. Today we'll be going straight to learning activity number 2. This first page will get you set up with Jupyter Hub and help you set up a Hydroshare account, which you should have done at the beginning of the module. If you have not done this yet, make sure you do it before you continue. We're going to jump right into it. We're going to come over here to open with Quasi Jupyter Hub. And here we are. If your page doesn't look exactly like this one, in the developer view, don't worry. As long as you can see these links here, we're going to click on National Water Model 1, Notebook 1 Visualization. All right, we are here. All right, so we're going to go straight to the bottom of it. This should look very familiar if you've already worked through exercises 1, 2, and 3 and watched the previous videos explaining how to do those. Exercise number 4 states, pick a single reach and plot its short and medium range forecast together. How closely do the forecasts match over their shared time interval? Knowing what you've learned about the National Water Model, why might they be different? All right, so this video is going to go over how to complete this exercise. If you feel confident, go give it a try. If not, here we go. Okay, we're just going up here to the bottom. Previous exercises, I've explained briefly what each of these cells do. I'll do it again. The first one, we're going to hit run. Make sure you hit run. If you don't, it's not going to work. A number should appear in the bracket, meaning that the code has ran. The first one's importing all of the packages we're going to need, like xarray to organize the data, matplotlib to graph. Come down here, run this one as well. This looks like big scary code. Luckily somebody else did it for us. But it's basically going out, depending on what reach ID we put in, which we'll put in a little further down, whether we want the short, medium, or long range forecasts. And it goes and grabs the URL and gives us back the data concerning the reach that we're looking for. And with that data, we're going to use matplotlib to graph it, and so we can analyze and observe the data. All right, we're going to hit run here. That sets up our variables. All right, we are going to skip this code because we want to compare some code side by side, and this code only allows us to look at one stream ID at a time. So skip this as well, this as well. All right, so we're going to use this. This is the same block of code we used for exercise number 3. All right, so the exercise asks us to look. Let's scroll down, make sure we do the answer the question correctly. It says, pick a single reach and plot its short and medium range forecast together. All right, so we need to come back up here to our old and faithful link to the interactive map, which is just below the matplotlib picture. right here, water.noaa.gov/map. And we understand. All right, you can pick any river that you want here. In previous exercises, we've picked the Colorado River, picked the Mississippi, the Missouri River. Maybe we'll spread it out and we'll come all the way over here today. We want to pick a big, thick-lined, vibrant color river, so it's a major river. Let's come right here. We'll do the Columbia River today. So we're going to click this portion right here. And we are looking for the Reach ID, which is what this is right here. Now, Reach ID works kind of like a barcode on your produce at home. The barcode lets the machine know when you scan it what produce you're checking out, so it charges you the right amount of money. Same thing goes for rivers and Reach IDs. The Reach ID allows the computer or the code to understand exactly what portion of river we're looking at. And, you know, this Reach ID is going to be different from this Reach ID because if you see right here, there's a little section of river coming in and out of it. And one over here as well, which is going to change the flow rate of this river right here. So that's why there's so many Reach IDs. Now, what we want to do is we want to compare the short range and the medium range forecasts. So we can do that two ways. We can use this interactive map, the computing programs that are already in this interactive map to look at that, and we can also use our code. So we'll do it both ways. All right. So first thing we're going to do is we're going to use the interactive map. So we're going to open forecast chart, click on this big orange button. All right, this is our analysis and assimilation period. This is right now. This is May the 4th, and it is 5:30 p.m. All right, and right now all that's plotted is the short range forecast, which goes out 18 hours in the future. We can see that it's selected and now it's assimilation. Okay. Now, short range is already in there, perfect, but we also want to come in here and we want the medium range forecast plotted on there. Now, you can plot the ensembles, all the different members, the predictions of what the flow rate's going to be in the future. But let's just do the average today, the 10-day forecast. Let's do the 8.5-day ensemble mean. That'll be the most accurate and most concise data to put on this graph. So we're just going to hit rebuild. There we go. All right, so we really only want to look. We can use these little sliding bars to zoom in here. We want to look at what's going to happen in the future. And we only want to look at this little section with the short range, which is the pink line, and the medium range, which is the long line. All right, so we can see the question asks us to compare and contrast the short range forecast to the medium range forecast. So the conclusions I draw from this is that the short range and the medium range forecast nearly mirror each other for most of the way until we get to about, let's see here, 6, 10, 15 hours in the future. The forecasts are going to separate slightly. Honestly, not that much, because if we zoom out here, you almost can't tell they're different. So they're pretty close to each other. Let's zoom back in. So there is a little bit of variance further out. What I can conclude from that is that, you know, as you go further in the future, there's more variability. Further in the future means predicting future flow rates is going to be more difficult. So of course, they're going to vary a little bit, but, you know, a couple hours in the future, we know it pretty well. We can almost certainly say what the flow rates are going to be 1 to 8 hours in the future. And seeing that the medium and the short range forecasts line right on top of each other really gives us that assurance that that is what's going to happen. All right, well, we completed the exercise, but now we're going to do it using our code as well. So we're going to come back here and we are going to copy this reach ID like we've done before in other exercises. Control C. We're going to come back here to our code, scroll back down here to this section of code here with the 3 reach IDs, and we're going to put it in. So we're going to put one there, and we'll put one here. Now, this code, we could go through and take the time to rename it. So we'd probably rename it the Columbia River short range, Columbia River medium range. And that's actually all this question asks for. It doesn't ask for a third one. We could do Columbia River long range forecast if you want to compare that as well. For the sake of this exercise and for time, we won't go through and change those right now. So we're just going to come down here and we need to change these. So for the Cumberland series, let's keep it on short range. It's already there. It only has one member, so we'll keep it with one. Red series, this is the same river, right? Same reach ID, same section of river, but we want to look at the medium range. So we're going to change this to medium range. Perfect. And then this one we could put long range. I'm just going to keep it a short range just for time's sake. It's just going to replot this one. It doesn't really matter. We just want to look and compare the short range and medium range graphs, and we'll just keep it as the first member. So there we go. And this is going to go out and plot it for us. So we're going to come here and hit run. Now it's going to take a little while because I have to go out and grab all that data again. All right, once it's gone out and grabbed that data, it should plot it for you. And so this right here is the short range, and we have 2 of the same plots, right? Because we were lazy and we didn't change this one. But so we're just going to look at these 2. So this is the short range, and it didn't change the titles for us either. We could go through and recode it up, but for the sakes of this exercise, we'll just look at it real quick. So we have a short range forecast and the medium range forecast. All right, so let's compare these. So the easiest thing to do is going to be come down here and run this as well. And this is going to plot it on top of each other. So this is basically the same thing as what we did here. The short range forecast is plotted on the medium range forecast. All right, so we can see here that it's not nearly as pretty as it was when we used the interactive map. So this is the first time I've seen this. So I'm going to draw some conclusions right now with you. There's a couple explanations I can think of why the data might be a little bit different. First, we got to remember always that there's 7 members in the medium range forecast, and when we plotted these, we just chose the first member, right? And it's not the average, so maybe the first member was a little bit drastic in its measurement, so that could be one reason it's a little bit off. The short range forecast looks kind of like we had here, kind of goes the same direction, and for the most part they reflect the same general trend that's going to increase in flow for a little bit and then it drops here. So those are some of the things we can look at and see maybe why there's some differences. Of course, we could come back up here and plot some different members and look at this graph again. But that is it for this exercise. Hopefully that all made sense. Hopefully you feel comfortable using the interactive map as well as the code to be able to reflect and compare and contrast different forecasts and feel comfortable doing those things. That is it for this 4-part video series. Stay tuned for the National Water Model Notebooks number 2 and 3, as well as notebook number 4 coming up soon.